But I guess many of you haven't used them exclusively to model whole applications, like the whole application. And I will show you here how it's done. This talk, it has two flavors to it. The first one is more or less tutorial. Like I mentioned, I will show you how to write such programs. And the second part, more important, I think, is it's meant to be an inspiration. Like, why should you care about those things? Why should you use immutable values to model your applications? And of course, there are usual answers to this question. Is like, okay, it's better in multi-threaded environments, right? Or it's better to read because those values don't change. So if people read them, they understand what they are, and they won't change. So they will be like that forever. But I want to show you a bigger picture. So to do that, let's go back in time to 2001. And Java was in version 1.3. I use Java as a mainstream language. It was trending back then. It was getting popular. Cool kids wanted to program in Java. Imagine that. And this was a simple language. It didn't have generics. It didn't have streams. It didn't have any concurrency, like high-level concurrency utils. So it was very simple language. But it, as I said, it was trending. So people wanted to program in that language. And the University of Texas, they were discussing this kind of switch. Let's switch the 101 programming sessions that we have, like the first semester language sessions, to Java, from Haskell, from functional language to Java. And a retired professor, Edgar Dijkstra, a professor of UT, heard this rumor. And of course, he opposed that. So he wrote a letter. It's still floating around the web. It's very short. But in this letter, he argued that it's very, very important to face students with the novelty of functional programming, because it drives home the message that there is more to programming than they thought. And of course, he meant students, right? That's like for the university. Students are the target audience. But for us, I think it's also important. So we can also learn a lot from other paradigms. So that's the whole point. We've been using imperative programming for like ages, right? And many of us, I'm sure majority of this room, started using imperative programming, like, some JavaScript tweaks on the website or Python scripts to do some small task. It's usually imperative. But we can learn a lot from other paradigms because they approach those problems differently. So what we can learn from declarative functional, so the other paradigm, we can learn that we can write programs and read programs by understanding the relationships between values instead of following step-by-step statements. Like operational reasoning is going through your program and keeping the context in mind. Always, like what happened before is always important or can be important in this line that we are analyzing. It doesn't happen with the declarative or functional paradigm. Only relationships between values matter there. That's why you can use rigorous reasoning. And I want to show you an example of that, like how other paradigms can shape our thinking habits. And to do that, I will show you two simple tools from two different languages. And one of them is Python, and second one is Scala. So let's go to terminal. I'll make it bigger. So on the left, you have Python REPL, and on the right, you have Scala REPL. And just imagine you are starting out programming in Python. So you don't know many things. You just want to hack things around. And you just say, OK, 2 + 2. And Python says 4. What happens when you say print 2 + 2? Also 4, right? So as you can see, this simple tool kind of like teaches you how to think about programs. There is no difference between 2 + 2 and print 2 + 2. While in Scala and other functional REPLs, it's not Scala, just Scala. When you say print line 2 + 2, you get what you expect, which is 4. But when you say 2 + 2, you get a different response. You get more information. You get like, this is a value. Its name is auto-generated, it's like res0. It's an integer, and it's 4. So it's a different thinking habit, right? And so this is an example of simple tool, and we are usually starting with REPLs. And at the beginning of our journey, we are exposed to different amounts of information, different contexts, and different perspectives. So what we can do in REPL here, everything is a value. So the whole talk will be just transforming one value into another. It's as simple as that. So we will use like strings. So let's say we have a string called AB. It's a name. We get a AB string, and also a CD, another string. Those are immutable values. When we say AB plus CD, we get another string, another value. Everything is immutable, so nothing can change. But we get a new value. It's called res1. It's a string ABCD. It can't change, and this relationship between values is right there. Here is the first value AB, second value CD, and the relationship is plus. So res1 will always be the same, will always be this ABCD string. And the same applies to lists. So we can have a list of strings, X and Y, and we're going to have another list. Let's say it's a one string list called Z. And both of them are lists of strings. In Scala and other functional languages, it's immutable. So when you say XY appended all, it's a function Z, we get another value. Res2 is a list of strings, immutable one, and it's, as you probably expected, XYZ, it's another list. And anything happens, anything like that happens with all the other ones, including, for example, a possibility of a value to not exist. Like option is the one. So when we say we have this XY list, and when we say head option, we get a new value, which is the first value from this list, if it exists, because some lists can be empty. So let's say we have an empty list string, doesn't have any, it's an immutable value as well, doesn't have any values. When we say empty head option here, we get a new value with the same type. It's not null, it's the same type than this as this one, but it just describes something that doesn't exist, but it's still an option of string. So that's how you build programs. And I know this is a simple example, but this is how we start usually, right? So it's two takeaways from this demo is that firstly, the tool matters. So when you start out with Python REPL, you miss a lot of information, context information. And the second one, when you do things declaratively, it's always like one immutable value or two immutable values that are transformed, but they are put together to create another immutable value. And when you start doing that, it changes your thinking. It shapes your thinking. Even the tool that you use and the paradigm you use, they all matter. So the three big takeaways from this talk, and the inspirational part stops very soon, so don't worry. Only three things that I want you to take away from that talk when we go through live coding and all those things is, first one, we can learn a lot from the other paradigm. Here it's declarative and functional. Second one is what we can really do doesn't have any limits. So let's see. What does it do? Here's a Java or imperative example of a code that goes through a list and doubles those elements in the list. And okay, probably you understand the code, but I want you to focus on like how do you come about understanding this piece of code. Probably you go line by line, right? You go, okay, first line is create a new list, which is 1, 2, 3, 4, 5. Second line is, okay, create another list, which is a result, for now empty. Now we have this for statement. It starts a loop, and then we go through each of the elements and we add a new value to this results list, and this is our result of the whole computation. So we needed to go from top to the bottom to understand the whole code. While in functional programming, it's just a relationship between values. So we just say, okay, numbers is 1, 2, 3, 4, 5. Doubles is a new value that that is using numbers value to create itself. So that's it. And we use map, as you probably expected, because it's ubiquitous nowadays. Again, something in, immutable value in, immutable value out, numbers in, doubles out. And map is the function that does that. OK, next step. So we will be now leveling up as we go. Let's say we have these strings, like TV show, The Wire, aired between 2002 and 2008. And this is the string that can be in the database or in JSON or whatever in the API. Doesn't matter. Let's focus on how we can parse this value. And by parse, I mean, let's extract the year start and year end from this string. Of course, the implementation doesn't matter. You just need to do some substrings or whatever. But the signature here matters most. So we want to get an integer out of the string, but sometimes we'll get an exception, and the same for the year-end case, right? But for let's say that we implemented it correctly, it will return 2002 for start and end 2008. But what happens when we give them another value, another string? For Chernobyl, which is a miniseries that aired in a single year. Sounds about right when we say that, but what happens is it blows up, right? Because we didn't really cover this example or this case in our code. And throwing exception is what usually happens in imperative languages. What we can do with that when we want to be declarative? As I said, it should be just immutable value in, immutable value out, always. So let's see how we can really do that when we first cover the usage example. So the problem with exceptions, maybe some of you don't know that, or you use exceptions all the time. The problem is with exceptions is that they are not composable. So whenever we see some kind of case that throws an exception, we need to cover and recover from that whenever it fails. So in this case, I know it's not the best one, but still, we probably want to cover the single year case as a catch. So we need to go line by line, integer year null. The same we did with the numbers case, right? Then we try to extract the year start, but if we fail, we extract the single year. Of course, we can fail again, but this is usually how we deal with those things in imperative programming. In functional, we have value in, value out. So we just have a signature that always returns a value. This value represents, option of int represents value that may or may not be there. That's the whole point of this type. And we'll talk a lot of different types in this talk. But this one represents a value that may not exist. So option of int means that we may return a value, but sometimes we won't. And this is all. It looks simple, right? But it gives us this confidence that it always returns a value. It doesn't throw. It always returns a value. And by doing that, we can compose those values. So as I said before, exceptions are bad because they are not composable. We need to use statements to recover from some failed cases. But here, we can use another function, or else, which takes two option values and returns the first one if it's some, or the second one if the first one is none. And that's all it did. And it returns year, the value year is another option. So we kind of build this thing together, and we can analyze rigorously what this program does by just going through all those values that won't ever change. Now again, or else takes two values, immutable values in, and returns another immutable value. So this is what we need to understand. What is it? Can be better in many cases, including error handling, but also in some more advanced cases, as you'll see, than just going through the hoops and lines of code like a machine. We are not CPUs. We can't really keep a lot of context in our minds. So this is really not helping, especially in bigger programs. So that's the first takeaway. The second one is like those tools and those new paradigms, they are kind of like shaping our thinking habits. That's another quote from this letter that Edgar Dijkstra wrote. It's like what we use shapes our thinking habits. So even if we use these functional things for a small toy project over here, what we learned can be used in our day jobs. And if that doesn't really convince you, there is this third argument. Brian Getz, he's an architect of Java language. He wrote last year, he wrote this data-oriented programming in Java article. And when you just look at this article, it talks about the future of Java and what we'd like to see, what kind of features. And when you look at the list of the features, you'll see records, sealed classes, pattern matching. Of course, we had streams and immutable like maps, filters, and all those things. So all those features from functional languages that we've been using in functional languages for at least one decade in mainstream ones, but decades before that as well, they are coming into those mainstream languages. And people are happy with that. And people are happy. So if those previous arguments don't convince you, please know that usually just getting to learn those things in a small language right now will help you later on, because either way, most of those features will go into the mainstream languages. Again, this passing immutable values around is a technique that is useful not only for lists, as I showed you, or even options. It's also useful for more advanced things. So the next app is the talking to the outside world. And this is where I will show you the real code. So the strings, list, options, it's usual tutorial online. You can find anything like that, like what those immutable values mean. But talking to the outside world, like the API, usually doesn't happen. And to show you the example of like calling the API using immutable values, I will show you an example, like a real one, and we'll try to run it. So user of this application that we will write will search for a tourist attraction. And this application will find this attraction and its geographical location, and will try to return movies that took place in this geographical location. So a peculiar travel guide. And as an example, if you search for Bridge of Sighs, this application should return, like it will be the terminal application. We don't have time for more. It will return a string like you search for a Bridge of Sighs, and this is located in Venice. Before visiting, you can watch Casino Royale, which has some scenes in Venice, right? That's a good travel guide, better than many online ones. So we start with a model. Usually, no matter what the paradigm, we try to kind of like model the whole business domain. And we'll have here a location ID, which is just a wraparound string, a location, which has its ID and the name, attraction, which has a name and a location. And we'll also have something that the application returns, which is a movie, which has a title and box office, like how much money did it make. We'll use it maybe for sorting, I don't know, just for fun. And of course, the output of the whole thing, which is travel guide, attraction, and the list of movies, right? Does that make sense? And we will use Wikidata. I don't know how many of you have used Wikidata or any like knowledge graph kind of like APIs or databases. Not many. So this link over here, query wikidata.org, it's open. So you can really do those queries. It doesn't matter what the query really does. It's SparkQL, by the way. So it's a query language for those kind of like knowledge databases. And you can, so since it's open, and we don't really have to have any authentication to call those APIs. It's for educational purposes, so it's like 5 requests per second limit or something like that. So we can learn a lot from that. But you can treat it as, for example, I don't know what you do in your day jobs. Is it like SQL database, NoSQL database? Usually you'll have some query language or something to query your data. And this is like outside world as far as your application is concerned. So for this talk, we'll use Wikidata. And for a client, we'll use Apache Jena, which is a like framework, Java framework, and it's imperative. That's important because many people say like, oh, I can't really do functional programming because all my like client libraries are imperative, right? And it's not true. And that's why I chose this one. Of course, there are some functional libraries that use semantic web and linked data, but I'd like to show you that it doesn't really matter because what matters is your application internals, not the clients you use. So we'll use that as an example. And this is like the query here. We just put it in a string. This is how this library works. So again, this is thinking like a machine, which is imperative library. That makes sense, right? We create a connection, usual suspects. We create query execution context, and then we have this iterator of query solutions, and we need to while loop until we have something. We just loop through those things, and we get some results. We print them out. That's it, right? That's imperative approach. So this is the library. It works. That's good because we just show the like URL query-wikidata.org, and we got some results. We got Yellowstone, Eiffel Tower, Table Mountain, with some IDs from this database that is in the internet. So we can use that for our application. But to use that, we need to model this kind of like calling this database as an immutable value. And this is where it gets a bit more advanced. So we had option, we had lists, we had strings. And those are like raw values. They represent a very small thing each. But here we have this value of type IO. And this IO of list of query solutions, this IO value is an immutable value that represents a potentially side effectful program that once executed successfully will produce a list of query solutions. That's how we should read this signature. So IO is an immutable value that represents a program. Immutable value that represents a program. And this immutable value that represents a program, it's not run anywhere. It's just representing what this program will return later on if executed. And we can just create those values by delaying a block of code. So some of you probably did something like that, like closures or things like that. So you get this connection query, which is imperative code of querying something, and you just put it in a delay. So it's not executed. It's just stored in this immutable value. So this piece of code is stored in this immutable value. And that's how we can model something as an immutable value. Does it make sense? Does it? Because people usually say, but okay, but that's cheating, right? You didn't call anything. And they're right. So just to make sure that we are on the same page, what does it do? Like when you say solutions program is an IO value, when we print this, print line solutions program, what do we get? What do you think? Shout out. Data? IO? IO, just we get exactly that in this example. So it's IO and 3 dots because we don't know. It's a value that represents something that hasn't happened yet. But what it also represents is a list of query solutions, this like output. We have the result type of something that will be executed later on. And this is what gives us those superpowers. Because if we have a solutions program, which is IO of list of query solutions, we can easily create another immutable value. Attractions program, which is a list of IO of lists of attraction, this internal model that we created, attraction, remember? And so we haven't really run anything. We can just work with the values and just, for example, map them, right? Map those things and parse those query solutions into our domain model. Again, we haven't really executed anything. We are just using IO values, immutable values, and we are mapping them, transforming them into new immutable values that represent new programs that internally use the old programs and map some values out, right? So that's kind of like working with the results of the program without running the program, and that's where the magic happens. So we transform the results without really having them. And when you look at the examples I've showed you before with lists, strings, and options, it's exactly the same paradigm. It's one value in, another value out. And we use map here, so as usual suspect, right? We get an IO of list of query solutions, and we get IO of list of attractions back. So let's try to use this a new IO value and try to code this demo I've been talking about. So before that, let's just recap what we learned. We have this attractions. This is what I showed you on slides, right? A print line is just IO. Attractions program is an IO of list of attractions. So we can create another value without even running anything. So we can create a value that represents a program that once executed will return a single attraction if any exists. Not the list, but a single attraction. What we should do here to create this new value? We have this one that is incoming, and we need to create another one, which is this one. So we have IO of list, and we want to create, using this IO of list, we want to create IO of option. What should we use here? Yeah, but we need to map because we are inside. Yeah, so we have attraction program, so we have a program, a result, and we head option, right? That's what we used before, head option, and that's it. So we just created a new program, a new value that represents a new program. And we can also have a list of programs because those are values, right? So we can have a attraction program here, and the second one. So we have a list of programs. And so this is IO of IO, list of IOs. And we can easily create a new program that runs all those internal programs and returns a list of the results, right? So instead of list of IO, we can have IO of list. And to do that, we have another function that does that, which is sequence. And that's all. So we get program sequence, we get a program. So instead of having a list of IOs, we have an IO of lists. And just to be clear, since we just use immutable values here, we can also run them. But this is the only impure thing in these applications. So we can say program unsafe run sync, and this is how it's executed. It's usually done in a framework, so you don't do that, but just to be explicit, this is the single line at the end of your program that runs your final IO. Yeah, so that's the recap. And let's try to write the guide. Here's the model again, location ID, location, attraction. That's what I showed you on the slide before. And we can now create our first and the final function, because this won't take long. Like when you saw those requirements, you probably thought about different approaches. But here is just one function that does several transformation of immutable values. So we have a travel guide, we have this data access, and data access are those things, those IO programs that will use Wikidata. But from this perspective, it's just an interface. Trait is just an interface that's not implemented, but we are implementing it as the SparkQL database fetching. And find attractions gets a name and the limit, how many maximum results we want. And this returns an immutable value that, once executed, will return the list of attractions. And the second one is find movies about location. Again, the SparkQL query underneath, but also represented as an IO value. So let's try it out. So in order to get it done, we need to find attractions with the given name. So that's what user gave us. For now, we just have one element. So we can be sure if there's anything, we just say head option. Head option. And then we can map this maybe attraction to something more. So we say map an attraction we need just to get movies, and we are done. So we found the movies about the location and also limit 1. Let's say, what's the type here of this one? So this is just an IO, right? When we thought about it, it returns IO of list of movies. So when we just map it again, we get movies and we create our travel guide. This is our output, which is attraction and movies, and that's mostly it. So when you think about the whole thing, that's how you program. When you look at the type of the value and you know what you need. So right now we have IO of option of IO of travel guide, which translates into English like it's an immutable value that represents a program that may return a new program, which will return a travel guide once executed. Right? That's the whole IO of option of IO of travel guide. That's how we understand that. And what we need to return from this function is IO of option of travel guide. So again, we have IO of option of IO of travel guide, but we need to return IO of option of travel guide. So that's kind of like, this is the rigorous thinking part, right? This is what's usually not very user-friendly at the beginning when you start out with functional paradigms. You need to think about the relationships between the values instead of going through your algorithm line by line like a CPU. So that's what we do. So let's try it out. We can map this whole maybe program because it's an option of IO. So I call it maybe program. And we just say, OK, let's sequence it. And then we'll get something different. We get IO of option of travel guide, and we can just flatten it if we want. But map and flatten, it has a shortcut, which is flat map. And yeah, and that's it. And that's how we kind of like create a new thing using just value transformations. And this should work. Let's try it out. So this is the whole implementation. We are done. Let's run it. Here, version 1, travel guide. I just run the whole thing. And again, there's like 5 RPS limit for Wikidata Open API. And we get a travel guide. We got the travel guide, bridge of sites. We didn't get Casino Royale. We got Spider-Man, Far From Home with this box office that Wikidata returned. So that's kind of it. And we can do even more. For now, it's just we are fetching a single attraction, just to show you. If we'd like to have a more advanced functionality, we can just say, OK, let's say 3. This will be then a list. We don't want to just get the first one because we don't know which location or which attraction is the best. So we can map these attractions into something different. And again, get 3 here, movies as well. This will return a different value. I want to show you exactly what this one returns. Let's see. This is IO of list of IO of travel guide. So a very similar one that we got before. So we can very similarly like flat map it and sequence it. But the most important thing is we now have a decision to make. Like right now, we have an IO of list of travel guides, and we want to return the best one. So what we can do is we can map it with a new function that doesn't work on IO values, just works on the values that we've seen before, like lists and options, right? So we can kind of like outsource the decision of choosing the right one, even if we didn't really run anything. This is just IO value transformations. We can outsource the decision to choose the right travel guide from the ones that we generated into another small function, which is travel guides. And we can just use the exactly same techniques of transforming immutable values into new immutable values. So we just say sort by. We have guide, guides movies. Like let's say we want the one with the most movies to win. So we just sort by reverse, and head option. And that's, and that's it, right? So we have this new version, and this one is a bit more advanced, but when you look at the structure, I know if you are new to this, it doesn't really matter if you understand the whole specifics. It's just like the thinking habits that are important, like transforming the values around and creating programs that look that do different things but look very similar in the structure, and you can really just analyze what happens here without really running any programs in your head. Just writing out or drawing the relationships between values. And if you want really to do even more things, you could use values that are even more advanced to simulate all those cases that you have in your real world applications. So this is like talking to the outside world, usually APIs, databases, what have you. But also, we can do like threads and resources and state. We can do anything really. So those are just examples of what you can do. The most important thing is that the technique is the same. The mechanics are the same. It's immutable value in, or several of them in, and one or several out. And let's see how it works with, like, I don't know, multi-threading. To give a multi-threaded version, it's very quick, because you just have to say, okay, I don't want to really go through each of those API calls in a sequence, as we can call them in parallel because they are independent. So we could just say parse sequence, we get another immutable value that represents a program that will run them on different fibers. And that's it. So that's the third version, which is concurrent. So again, another value transformation. And resource safety, for example. Another technique that you usually have in mind when you think about problems in your applications. So how does it work? You want to take a guess? What do we have for resource safety? This is like statement or try-catch or something different? Immutable value. Immutable value. So yeah, we have immutable value that represents a resource that needs to be acquired, used, and released safely, no matter what happens. So yeah, it's called resource. So when you look at what I did before, it's like I unsafely created this RDF connection, and then I needed to close it. So if anything bad happens in between, we can like leaking resources, right? Leaking these connections. So I need to make it safe, and that's why I use this resource value. So resource of IO of RDF connection. So this means that this is a resource of RDF connection. So value that represents acquirable and releasable resource. And it has a constructor. The constructor just takes two functions. The first one creates the resource, and the second one closes the resource. And this is all we need to create this value. And this will not run anything. So here we just say IO delay and create connection unsafe. And the second one is connection that returns a program that closes it. Again, we're just wrapping the unsafe calls inside IOs. And this is a value that represents this resource. And how can we use it? Well, we can create another value called program, which is an IO value that we all know. And to do that, to create a value, this will represent a program that will run our travel guide implementation. The same, I haven't changed anything, because we are now in a different phase of implementation. The business logic is done. We are not touching it. We are just adding another layer. That is resource safety. So we just get a connection resource value, and it has this function called use. And this function called use gets a function from connection to a program. And we can just version 1 or version 3, whatever. We can just call our program with some Wikidata and bridge, let's say. And this will not leak. That's the whole point. So I'm just creating whatever I created before, exec query here. That doesn't really matter. What matters is here, if anything happens, bad happens here or wherever, we will still not be leaking anything, because this resource value represents all the mechanics that we need in order to be safe in this environment. So that's more or less how it works, and we can even do the same thing with state and having some value in the multi-threaded concurrent environment. So all those things are really done using just immutable values that represent them. And okay, of course, we have multiples. We have list, options, and strings, as you see, IO, ref, and resource, which represents those like API calls or unsafe external world, resource safety, ref, which is the like memory accessible from different threads, but also traces like Datadog or anything like that, or loggers, HTTP endpoints. Everything has a library or a value that represents them, and you can just transform them together using map, flat map, and other functions, creating new values out of them, and using resources and IOs in between to make sure it's all safe and useful. So again, 3 things that you can take away from this is, we don't have to think like a machine. We don't have to look at the whole program, keep everything in mind, just imperatively going step by step, reasoning operationally, debug as we go, like CPUs, like the machines. We can try to write some programs differently using just immutable values. I know it's difficult, especially at the beginning. It's for everyone. It's difficult for everyone. But once you get the grasp of it, it's really nice, because you then use your knowledge from the previous, like lists and strings and IOs and resources, to learn new. Can you hear me? Yeah. Second takeaway is, okay, we can really take those things, try to implement them. Maybe we succeed, maybe we not. But just looking at those things, it's all possible. So everything you want to implement is possible using this paradigm. That means that you can learn a lot from it. And of course, use in your day-to-day applications, even in small parts and small bits, not the whole applications, but parts of it. And finally, when you just go back and see what happens right now with all the programming languages, like mainstream programming languages, what kind of features are going into Java, for example, it's like functional, like it's pattern matching, it's record, sealed classes, it's map filter, streaming, everything like that. It just lands and people are happy. So we can just start learning right away with the languages that already support those features. What I showed you here is like the last chapter of my book, or last few chapters. It's divided in 3 parts. And the last part is this whole application that uses immutability and functional programming. But the first 400 pages is like intro to that. So taking like step-by-step approach, small steps, baby steps. And yeah, I have a few books for you. Just grab me here or at the book section and downstairs. And there's a code here you can use to buy new ones or recommend to a friend who wants to learn functional programming. My name is Michał. All the codes, the book stuff is in the QR code. Here's my Twitter and my webpage. Please have a visit. Grab me during the rest of the conference. I hope you enjoy that. And yeah, have a great day. Questions? Sorry. Do you need to debug? Of course you need to debug. The cool thing is if you are used to imperative debugging, it still works. You can set a breakpoint in your function that you pass to map, and it will stop when it's there. So if you map a result of an I/O function, of an I/O program, I/O value, once you execute it, it will stop on this breakpoint. So you still can do it if you need, and it's nice to get from a point of imperative into declarative because those tools still work. Thanks. Anything more? Okay, thanks a lot. Enjoy the rest of the conference.